Wizard.
Hi. Come on up here. See, here's a mirror.
Yeah?
You see the light from it?
Uh-huh.
Now watch.
You're reflecting it.
You hear the music?
Yeah. How come the music goes on when you reflect the light?
Well, you'll find out later today, because today we're going to investigate a special kind of radio waves.
Radio waves?
Yes, here, let me turn this down. And I'm going to set up a problem for you. Have you ever been a radio astronomer?
Not lately, no.
No? Well, that's the problem I'm going to set up, and you have to discover a galaxy out in outer space.
Now, how am I going to do that?
Well, here's galaxy number 1, see?
Oh, pretty small galaxy.
Yes. And over there is galaxy number 2.
Mm-hmm.
And they're not visible to the telescope. If you look at the sky, you wouldn't be able to see them. But come with me to your radio telescope.
This?
Yes. Now, someplace over there is a galaxy that is sending out signals. Listen. Hear that?
Yeah, a little buzz.
Yeah, I'll turn it up now.
That's coming from one of the galaxies?
From one of the galaxies. I want you to tell me which one.
Well, how am I going to do that?
Well, see that over here there's a meter?
Yeah.
Now watch what happens as I turn it. See how it
goes up and down.
Goes up and down. And notice that I have, along the side here, I have degrees.
Uh-huh.
And I've got this right on a mark that I put on the floor with tape. And what all you have to do now is line this up very accurately by looking at the meter,
Yes.
reading the degrees on here, and we can make a record of it. And I think by the time you'll see that you'll be able to identify which of the two galaxies it is, Galaxy 1 or Galaxy 2.
Okay.
All right, try it. Line it up carefully. Now, can you see the meter there? And line it up so it's as high as possible.
About there.
About like that? What does it read in the degrees?
90.
90. Okay. Now here's the way a radio astronomer might do that. See, here I have drawn out on this sheet of paper the map of the sky.
Oh.
See, that may not look like a sky.
No, it
but you
doesn't.
see, there is a galaxy,
Uh-huh.
and over here is a galaxy.
Right.
See, these two galaxies? And here's the point at which you just made your first measurement.
Okay.
And what did you find that the angle was that the radio information was coming from here?
About 90 degrees.
Okay, here's a protractor. You know what to do now? You put it right down here
Well, let's see.
and mark it at 90.
About there.
Right there. Okay, now you know that the signal from one of these galaxies is coming in on that line. You want to draw a line down there? I'll have to move it up to continue. Just a minute. Like that. So you know that the signal is coming in someplace along that line.
Someplace along there.
Okay, well, which one is it?
I don't know. It could be any one.
Well, how are you going to find out?
Well, I guess we have to make another line.
All right, let's make another line. I anticipated that you might want to do that.
Oh,
so I
good.
have marked a new spot back up there in the corner. So let's take our radio telescope and put it up there.
Very convenient.
Isn't that nice? Now I have marks all on the floor for you, so it's
Okay.
lined up along a line, like that. And now if we turn this on, see if you can find the noise again.
One of those galaxies, huh?
Sweep it all the way through.
Well, there.
What does it read?
It's about 60.
About 60?
About
Okay,
that.
now what do you do?
Make another line.
Okay, make another line.
All right.
Now, see, what I did is I put the first radio telescope reading here, and I have measured this out on the floor, and we're right there at that point. So now what do you do?
Well, let's see. Put the protractor there
Yeah.
and make a mark at 60.
All right.
Right there.
Okay, now what do you do?
Well, draw the angle.
All right.
Yeah. Okay. Well, I think we found the galaxy.
Yes. This one, this one was number 1,
Yeah.
and this one was number 2.
Must be the second one.
As a radio astronomer, you say that this is coming from galaxy number 2.
Yes.
All right, let's go find out.
Well,
You got on your spacesuits?
Oh, yeah.
On a spaceship. so we can just go zooming through here.
Okay.
Here's galaxy 1. We can check that quickly. You see it's a empty box. Okay. Let's check galaxy number 2.
Aha.
See?
That's right.
That's right. You were right. And this is a little radio transmitter that was sending out a signal, and you were able to locate it. Now, actually, they use this in places other than in radio galaxies. They do this in radio direction finding.
Isn't that radar? You know the way it works, sends out things. And
What is
everything?
radar?
Well, when you want to track something, for instance, if you have an object and it gets in the path of the radar signals, it's recorded.
Well, but what signals? What are you talking about? Do you know?
Well, the waves.
What kind of waves?
I guess radar waves.
Well, I think I can figure out. I've got a method set up here whereby you can find out for yourself if it's radar.
Oh.
Here.
Okay.
I'll show you. You come around over here on this side. And this is a little transmitter, the one that was sending out the signals over there, you know, in our galaxy study. And here's where the signals are coming out, little waves. This is a receiver. If I put the receiver on like this, I can slip it on. You see the little meter stick I have up here?
Yeah. Ruler.
The little ruler. Now, what happens to the meter as I move it in and out? You see how it moves in and out?
Yes, it goes up and down.
Yes, it goes up and down.
Just like the other one.
Yes, and now I'll move it out here so it gets pretty close to the low spot, because I want to show you now what you're going to be doing. The waves that come out here are sine waves. Just see that one over your head there?
Oh, yeah.
See? And there's a low point right here. This is 0. So the meter should read as low as possible here. Now as you move it further and further away, you could see that if you were receiving this signal, it would get stronger and stronger and stronger and stronger, and then it would get weaker and weaker and weaker and weaker and weaker and weaker until it finally came back here to 0 again. Then if you continue with this particular kind of meter, you would also get a high reading coming up here. This is positive and negative, you see. So that you get a high reading here, and then it would go back to 0 again. So this is a wavelength from here to there.
Oh,
That distance from there to there. So all you have to do now is get the meter to read as low as possible, and then go up high, and then come back down here until it reads 0 again. And what will you have?
The measurement of this part.
Half a wavelength. That's right. Okay. Well, let's try it.
All right.
And you can tell me then whether it's radar or not.
What do I turn this?
Turn that little knob back and forth like that, and that's a very careful adjustment, you see. So now, which way is it going?
It's going up.
Okay, so you pull it back here till you get the lowest possible spot. Go ahead.
Huh? It's past it.
Okay,
Right
now.
about there.
Okay, now you can read right up here where that point is. What does it
It's
say?
about 18.102.
18 point. Well, I'll call it 18.1. You want to write that up there? Nice big, right down here.
Okay.
18.2.
18.
That's
Two.
centimeters now.
Okay.
Okay, now what do you have to do?
Find the next one.
Okay. Pull it back. I think that might be easier.
And it's going up.
Yeah.
There it goes.
So you're at the top of the peak now.
I'm at the top now.
Okay, now you work your way back.
Now it's going down. Here it comes. A little more. About there.
Go through it once and see. Are you sure? Yeah. It's going up.
Yeah, about there.
Okay, now, I mean, a good idea to always go through it a little more. You see on both sides? So to make sure it goes up again. There it goes, you know, so it's down right about like that.
Uh-huh.
Okay, what does that read?
It's just about 20. Not quite.
Not quite 20? Okay, 20. Now you found that this distance from here, this mark on the ruler was 20.
20, so...
Okay, so put 20 there, like that. Okay, what's the half a wavelength? How are you going to find out?
Subtract that.
Okay, you put 20 up here and subtract.
Alright. Well, that's actually 19.
Yeah, 19. All right.
Alright, so you have... That's 8, and that's... So it's
1.8.
about 1.8.
Okay, if that distance is 1.8, what's this distance?
The same thing.
Yeah, so that, what do you have to do?
Add
one. All right, add
So
1.8.
1.8.
And what have we got?
So you have about 3.6.
Okay, right, 3.6. Okay, that's the length of the wave, 3.6 centimeters. Now, it just so happens that you were writing right on top of the thing that'll tell you whether it's radar or not.
Oh, that's sneaky. That's not fair.
Here, this is the whole electromagnetic spectrum. Here are radio waves down in here, see?
Uh-huh.
And then here are infrared, you know, along the heat waves.
Yes.
Here's the visible spectrum, the colors.
Uh-huh.
Here's ultraviolet, see, X-ray,
X-ray,
and gamma rays way out here. Now this part of the spectrum, the radio part here, with this little line here, has been expanded.
Oh, then these are all
Radio waves, and notice this says 30,000 centimeters.
30,000 centimeters.
All right.
3,000.
3,000 centimeters.
300.
300 centimeters.
30.
30 centimeters.
3
3
centimeters.
centimeters. And what did you get? 3.6.
3.6.
Okay, there's 3 centimeters. So 3.6 would be up there in just a little bit.
That's radar.
Yes.
Oh, right again.
So you are able to identify it yourself. And notice all the frequencies around in here, see?
Yes.
Radar here, microwave relay, space telemetry, radar, microwave again, airborne radar, you know, the ones that are carried in planes, and microwave relay. Remember that, because we're going to be investigating it later.
A lot of waves.
A lot of different waves, and depending on the frequency, and the one that you happen to be using is 3.6. Now notice, this is true, that this section of the spectrum is this part up here.
Yeah.
Every time you go from here, you're adding a 0 to the wave, or you're subtracting a 0 from the wavelength. Notice where light is? 1, 2, 3, 4, 5. 5 zeros you have to add to light to get this, or subtract from that. And notice what a big difference there is?
Yeah, it's quite a difference.
These are very short, aren't they?
Yes.
And these are much longer, about 3.6, 4, and so forth. Well, now remember that, because I'm going to do some things with light, and then with these microwaves.
Will the same thing happen?
Yes. Oh, by the way, I just used that word microwaves, and I wanted to make sure you understood that this is not radar. These are microwaves, waves that are not as long as the radio waves, but not as short as light and infrared, but micro, kind of in between, 3.6. So that they are the kind of waves that are used for radar, but they're also used in microwave radio relay towers and other things like that. So you shouldn't really refer to it as radar, because that's a special application which you are going to use before you leave.
Okay.
All right? Let's try to now compare them to light. You remember that mirror I had when you came in?
Yeah.
And here is a light out here, and I'm going to turn on this, start the record over again. Turn up the volume. You don't hear anything, do you?
No, not a thing.
Well, the signal from the record is coming over here and being sent into the little microwave transmitter. That's out here. See, I put on the other side.
Yeah.
Come out. See, it says transmitter.
Uh-huh.
And here is a little receiver.
Oh.
And so if you put them here like this, wow.
You can really hear the music.
You see, hear the music?
That's pretty clever.
So the microwaves are coming out of here, carrying the music on them, and going into the receiver here. Now I'll put the receiver down like this, and you take this mirror, and see, I've got a light set up above so that you can shine the light and the microwaves into this and bounce them over here.
Oh.
So you try it once.
All right.
Now you're a little low, you're not picking up the light. There.
There it is. Yeah, you can hear it.
Yeah.
And you see the light there, too.
Yes. So what kind of conclusions do you come to as far as the kind of waves they are?
Well, they're both the same, almost.
Well, that's true. They're both almost the same, but let me see if I can show you the difference. You can focus reflect the light waves and the radio waves, but watch this. Here's a piece of, well, that one's got some holes in it. Let me take this one. Here.
All right.
Piece of screening that you would put in front of a radiator or something. You hold that up there.
You can hear it, but there's no light.
Why not?
Well, the light's going through. But why
You can see the light hitting here.
Yeah.
Some of it is reflecting off, but it's certainly not enough to get over to here and light this up.
Well, why aren't the other waves going through?
Well, see if you can figure it out now. Why? Remember, I showed you on that spectrum chart the difference in the wavelength of light and the microwaves that we're talking about. Why should the light waves go through this and the long? First of all, we said 3.6 centimeters.
Yeah.
That's about 1.5 inches or so. So how long does that wave come here?
Oh, it's too long to get through.
Does that make sense?
Yeah, it can't get through the holes.
In other words, the wave is so big here that some of it is reflected from this.
Yes.
What about the light wave?
Well, the light waves are much smaller. They get right through.
Yes, they can. Some of them are reflected here, obviously, because you can see the light.
Yeah.
But they are not reflected back over here. Primarily because, as Dr. Shaman says, it's not quite the proper explanation, but it's a very logical one and does fit. Okay?
Okay. I'll take your word for it.
Well, now you can do some other demonstrations that involve light. You remember this rod.
Oh, yeah. You could
How
put
you
it
can
over the light.
Put it over the light. You can see it.
Shine
It shines through like this. And you remember why that was?
Well, because the light goes around and it's reflected off of the sides and then comes...
Off the inside surface.
Yes.
Yes. Well, watch this.
It works with the other waves.
Yes.
Goes right through. So they're alike in that way, aren't they?
Yes, you can bend them both in a sort of a wave guide this way, but let's try it with this one. Here, you want to look in there, see, do you see any light coming out of there?
No.
No light coming out of there.
No, no.
Okay, but now watch what happens here.
You can hear the music. It's a music bender.
Also a lot of static.
Yeah.
Yeah.
But you can't do that with the light.
Well, why not? Now, what would the difference be? Why would the light not bend around here?
Does it get trapped in the coils or something?
Well, the wavelength again, you know, it could be absorbed in this very easily. But the wavelength we're dealing with, 3.6, or something like that in this
Just
case,
goes right through.
it bounces off the inside surface of this and finally comes out the other end. Isn't that neat?
Yeah, it's pretty good.
Then, another thing that you can do with a mirror or with a surface, let me put this around here and show you. Look, this is what I was doing when you came in. If I place this here, I can shine both the light and the microwaves at the receiver, right?
Yes.
But watch.
You're bending it.
Now, you see what happens?
When you just move it just a little bit, you don't hear the music.
Yes, it sharpens the beam up very... Well, look, see what it does to the light? You see?
Yes,
How
it
it's
makes
wide
it,
there, and then it gets nice and narrow.
Narrow.
Well, it's doing that same thing with the microwave. So this is why I can
It's
focus
like
it right here.
focusing it.
Now, if I turn it around like this and do it in this plane, see how wide it is?
Yeah, it doesn't work as well.
Same thing with the light, too. It's
Yeah.
not reflecting much, but... So this is called a parabolic reflector, if you get it in the form of a parabola, and you can get a very sharp and very strong beam by getting it focused just right.
Oh. Sounds much better, too, louder.
Well, that's because all the rays that are hitting here are now being bounced back and concentrated on one spot. I'll see if I can get it real loud. I gotta get it right at the focal point.
Don't break the mirror.
All right, the record, Rab. We gotta wait till the next
Oh.
section comes up in the record. Now wait, it'll be up in a second. Now watch.
There it goes. If you just move it away a little, it doesn't
Yeah,
work.
see that? How it's very sharp. Now it would work in this plane too, wouldn't it?
Yeah, I guess
You
so.
see?
It's not as sharp, though, is it?
Well, that's because of the way I've got this light set up. So,
Oh.
so the point is, you now see that the same sort of things that you can do with light, you can also do with microwaves.
So they're like in that way.
And you know that if you take a little a bulb and put it in the middle of a reflector that's bent this way and this way, you could have you can have the light be reflected out like a reflector in a flashlight.
Yeah.
Well, that's exactly what they do over here. Look.
Oh, yeah. The round bowl.
Yes, you see how this bowl is shaped now, not only like I shaped it half this way, but half this way, right? And where do you suppose all the waves that are hitting this thing will now be concentrated?
I guess on that.
Right here at this little point.
Uh-huh.
Yes, right here.
Is that an antenna?
So that's the antenna.
Huh.
Isn't
That's
that neat?
pretty clever.
Yes. So now you can very, very carefully aim this with waves coming in and get them quite strong and concentrated right there. Now, and the same thing would be true if you were transmitting. You could send the waves so they'd come out all over they'd come out from here. They would go out in all directions, hit the dish, and they'd go out in a thin little beam too, wouldn't they? So you could very
Yeah.
carefully aim it this way as a transmitter, or very carefully aim it this way as a receiver. In fact, let me get that radio telescope that you were using.
There it
Set it
is.
up for you again. You'll see that's exactly what you were using before. Look. You see?
They have something like that around airports and everything, don't they? You know, all kinds of things. They have the thing that turns
That
around.
turns, yeah. Well, that's the radar, and we'll get to that in a second. Here's the one that you were using, a radio telescope.
Uh-huh.
And haven't you ever seen pictures of radio telescopes? They're huge, dish-like things. Sometimes they even have holes in them. They're just made of wires, and they're great big things set on the ground.
Oh, yeah.
You know,
yeah.
they're sitting like this. On the ground, because they're you know, getting the radio waves in from the sky.
Is that the same thing?
Same idea, yeah. You just did the same thing. So, if you could set this up so that this is a receiver, and radio waves are coming in here and focusing down here. Now this is a little amplifier here. Let's turn it around like this and assume that they were coming in this way, now that you've seen that. Now if this were a little amplifier, you could now get a transmitter and set it up over here, right?
Yeah.
And the transmitter would now send out the waves on this side.
Then you have it coming and going.
Yes, you'd have them coming in here, being amplified and coming out over here. And you've seen double dishes like that sitting on top of a building or on top of towers, haven't you?
Oh, yeah, they have them around police stations and things on the highways.
Yeah, on the thruway. The police station will have 2 of these. And what they're using there for is, we sent music over it, but you could also talk over it.
You can?
So, yeah, so they're sending their telephone conversations in this side, comes down, goes into the station sometimes, comes back out, is amplified and sent on to the next station. And that's what's called microwave radio relay tower.
Oh.
And that's what we just have when we set this up. And you remember some of those frequencies on the chart were microwave radio relay?
Yeah, one of them.
Yeah. So, and they use telephone calls too. And television programs are sent over a system like this. Well, that's microwave radio relay. But the one you were asking about at the airport is radar.
Yeah.
And I have a radar problem set up for you. In fact, flying around in this, well, not really flying, but flying around in this room are airplanes.
Where?
Well, they're hidden.
I don't see it.
It's foggy.
Oh, great.
So you can't see the airplanes.
Okay.
But with the radar, you could detect them, can't you? That's what they use them for at the airport. Well,
Are the enemy planes or friendly planes?
well, let's say this is out at Kennedy.
Okay.
Okay. Now, in a radar, remember we saw how you could have one of these as a transmitter, you could have another one as a receiver. Well, if you first use this as a transmitter and you send out the radio waves, they go out in a little thin beam, right?
Yes.
Now you could shut this off.
Well, why?
Well, because when a radio beam bounces from that one, from something that, some metal object or some object out there like birds or clouds or something,
Yeah.
the radio waves are going to be sent back here. Now you switch this off from a transmitter and you make it a receiver.
Oh.
Then you would receive those signals, they'd be put down here and you could put them on the scope, with the sweep going around.
Yeah, with the lights.
So you're using the same dish for transmitter and receiver, you just turn it off. And then what do they
Two in one.
Then what do they do?
Then they have it turning around.
So you can sweep the whole sky. Mm-hmm. Okay. Well, now that's what you can do. You're going to sweep the whole room to find these hidden airplanes.
All right.
But we can only have this as a receiver. So I'll put another transmitter on top of it. That's not the way they do it, but that's the way we'll do it.
Okay.
See, here's the tower, the transmitting tower. And here's the little transmitter. See? Mm-hmm. Okay. Now, radio waves are going out over here. Whenever they hit an object, they're going to come back and be focused back down here. And back here is a volume control. So you come around down on this side.
Okay.
And I'll turn up the volume control. There, hear it?
Yeah.
See?
Got a little louder there.
Yes. Okay, well, now you investigate the room, and you're the radar operator.
Okay.
And you investigate the room, and what's going to happen when the radio waves are bounced back off of something?
I guess it'll become louder.
All right, try it.
All right.
Sweep through once, let's make sure.
Out there, I think, maybe.
Yeah, well, you can sight right over the top and see what it is.
Looks like it's aiming at that box.
Well, let me check.
Must be a pretty small plane. I'm right.
See? Now, why did it bounce off? See if listen if it is that. Watch.
Yes.
Now, why were you able to detect it?
Well, because the waves bounced off of that and then came back.
Yes, and notice I made them out of aluminum foil because it's metal.
Oh.
And would bounce in. And notice it.
When you get in the way, it doesn't work.
It doesn't work. Okay, you found one. Try
Do you have
again.
any more?
Well, I don't know. You'll have to find out. Go the other way. I'll give you a clue.
Oh, okay. Thank you. Sounds like it might be getting a little louder around there.
You suspect something, I assume,
yeah,
by now.
let me sight in. Yeah, I think that box.
All right.
You're running out of boxes. Right again.
Right again. And notice I had to prop a towel under this one because it's very directional. Look.
Yeah.
See it?
Slightest movement makes a change.
Okay, you have 2 airplanes circling the airport. Any more?
Well, let's see. Sounds like there might be one over there. I don't see any box.
No
or
box.
anything. Wait a minute.
What?
What's behind that chart? Aha!
You discovered
Another plane.
another airplane.
Any more?
Well, that's all I put. Maybe you'll find some that I didn't have around. In fact, any kind of metal object, if you happen to be using, you want to turn that buzz down?
How do you do it?
Let me just turn this on a bit.
Oh.
If you would swing this around, you could pick up water pipes. If there were a steel gutter, thing coming down,
Anything.
rain spout, or if you had it finely tuned, I suppose even conduit with electrical wires inside, you'd pick them up and they also use it for bouncing off of clouds. You don't just need a metal object.
You don't?
No. Have you ever seen in the pictures in the paper where they have a radar sweep and they show big pictures of clouds? And during the war, if they were looking for enemy airplanes, very often they'd get a cloud of birds going by, and signals would bounce off of them, too.
It'd be confusing.
Yeah. Well, evidently what happens is that when the signal goes straight out through the air, you don't get any bounce back, and if it hits an object, even a non-metal object, some of the reflection can come back. So that's how they can use it to check hurricanes. Anyway, you just, congratulations, you're an excellent radar operator.
Thank you very much.
You'd now be in control of these airplanes, right?
Huh? Didn't even finish school yet.
And you would also send, you'd talk to them via radio, wouldn't you?
Yes.
Yeah. Okay. And as they moved, what would happen to the blips on the little screen?
Well, the blips would move.
Yeah. Well, now, this is probably the first time you've ever experimented at all with microwaves. What are they kind of like?
Well, they're very small.
Compared to what?
Compared to light.
No.
Visible.
They're very small compared to radio waves.
Oh, that's right.
Yes, yes.
Radio
yes.
waves.
Light waves are very, very tiny indeed.
And they're large compared to the
Yes.
light
Yeah.
waves.
Well, here, let's see if we can demonstrate it as we're talking over here, and you can see. I'll turn on the light, and I'll turn on the record player again, and we'll see if we can see them. Watch. They're like light, and yet not like light, right? You want to turn the volume down there just a little bit? So you see they're like light, and yet they're not like light because they're much longer, right?
Yes.
Okay. Turn it down one more. You're turning the wrong way.
Oh.
Now up a little bit. There we go. Now the music is stopped. It'll be back. There we go. Turn it down. There we go.